Hi and welcome. In this video I'm going to be sharing information that relates to a chemical straightening service. As we know, a chemical straightening service impacts on the cortical fibres of the hair, and it differs greatly from relaxing a permanent wave that we have studied in earlier years. We're going to be looking at the chemical and physical action of our chemical straightening formulations on the hair shaft. We're going to be looking at the different types of chemical formulations. I'm going to talk briefly about hot and cold straightening formulations and selecting formulations to suit hair types. There are resources that are available to you at Inditech Online, and you can read those in addition to this video. The physical action on the hair is we are changing the cortical fibres in the hair from curly to straight. So let's start first looking at the different formulations that we have for our services. The two common formulations are hydroxide formulations and thio formulations. The thio formulations are the ammonium thioglycolate formulations similar to PERM solution, whereas the hydroxide formulations include our sodium formulations in addition to our no-lye hydroxides such as potassium, guanidine and lithium hydroxides. Before I go on to our chemical action on the hair shaft, we need to first understand the difference between a lye and a no-lye formulation. Lye formulations have been derived from wood fire ashes or potash, and they are extremely caustic and harsh on the hair shaft. Predominantly our sodium hydroxide formulations are lye formulations. Our no-lye formulations include our potassium hydroxide, our lithium hydroxide and our guanidine hydroxides. Now these no-lye formulations are not as strong as a lye formulation. The risk with a lye formulation is that it can cause scalp sensitivity, and it can also cause sensitivity to the hair, which is why many formulations use a no-lye hydroxide, which is gentler on the hair shaft and is less likely to cause scalp irritation or scalp sensitivity. Moving on to the chemical difference between an ammonium thioglycolate chemical straightener and a hydroxide straightener is the process and the action on the cortical fibres. A sodium hydroxide formulation will cause a different chemical action. And before we start that, it's really important you understand the diagrams here, which will illustrate a lanthionine bond and a disulfide bond. So now let's look at the chemical action of hydroxide straighteners. Now this is where it varies distinctly. These are our polypeptide chains, and across the hair structure prior to any chemical service we have disulfide bonds. A disulfide bond looks like this diagram here, where we have two sulfur atoms within the cortical fibres that are joined together to create a disulfide bond. The chemical action of a hydroxide straightener is that during the reduction process it reduces the disulfide bonds to a single sulfur bond. Now this bond is called a lanthionine. The process is called lanthionization. So just to cover that again, when the hydroxide solution is applied to the hair, the disulfide bonds are reduced to a lanthionine. The process is called lanthionization. The reduction of the disulfide bonds takes place, reducing 30 to 70% of those disulfide bonds to lanthionine bonds. Now remember that we will still maintain some of the disulfide bonds in the hair, otherwise the hair structure would be completely weakened and very likely to fall apart. This is a close-up of a lanthionine, and you'll notice that the difference between this image and this image is that it only has one single sulfur bond, whereas in here with the disulfide bond we have two sulfur atoms joined together creating that disulfide bond. So the chemical process, just to recap, of a hydroxide straightener is that the solution is applied, the reduction takes place reducing the disulfide bonds to lanthionines. There is no need for neutralizing because you cannot rejoin or reproduce a disulfide bond. And this is what makes this process so incredibly different to a thio process, where we can just temporarily reform our disulfide bonds. What happens is we use an acidic shampoo and an acidic conditioner to change the alkaline of our product back to close to the hair's natural pH. In this diagram, we look at the chemical action of a thio formulation on the hair. And if you remember your chemical action of your perm solution, you will remember that these polypeptide chains and these are your disulfide bonds. Now, the ammonium thioglycolate formulation is applied to the hair. The hydrogen from the solution is attracted to the disulfide bonds. It reduces those disulfide bonds to single sulfur atoms. Now, not all of those disulfide bonds are going to be separated. Once enough of the disulfide bonds have been reduced to single sulfur atoms and the hair has been separated, the hair is rinsed and a neutralizer applied. Remembering that the oxygen from the neutralizer is attracted to the hydrogen, which allows the disulfide bonds to reform in the new shape of the hair shaft. So just recapping, the disulfide bonds are softened and broken using the thio formulation. The hair is rinsed and a neutralizer applied. The oxidation rejoins the disulfide bonds with the hair in the new shape of straight. So now that we've looked at the chemical action of our products on the hair shaft, I'm just going to remind you the difference between your thio product and your hydroxide products. The hydroxide products' chemical action on the hair shaft is completely irreversible. So once a client has had a hydroxide straightening service, they cannot have a perm to create wave again until that hair is grown out. Whereas the thio formulations are reversible. So in the future, if the client decides she would like to go back to a wavy look, she has the option to do so. I'm now going to talk about hot and cold straightening services. There is information in your resource regarding this, and it stands to reason that a cold service is a formulation that is applied to the hair and the service is provided without added heat. So the value of a cold straightening service is that it's a milder and gentler process and has less impact on the hair. It's really useful for somebody who just wants to relax their natural wave. So the two key factors with a cold straightening service are no thermal heat is applied during the service, and there's no thermal preparation of the hair shaft prior to the application of the product. You will also find that a cold straightening service is slightly gentler on the hair, so it's best used on fine hair where you're not having to straighten too strong a curl. With a hot or a thermal chemical straightening service, you'll get a much better result with a thermal straightening than you do with a cold straightening. Predominantly the hair is straightened with a thermal iron prior to the application of the straightening product. Thermally straightening the hair shaft prior to the application of your formulation makes it easier to apply, which will give you a much better result. Remembering that the pre-straightened hair, the hydrogen bonds have been temporarily reformed to straight, so it allows the formulation to work on an already pre-straightened head of hair. This is a much more efficient process and gives you more longevity and lasting with your service. Now let's talk about the formulations to match the hair types. It's really important to take into consideration several factors. Hair type, the degree of curl that you're reducing, the state of the hair, making sure that it can take the straightening service. You're going to need to consider the formulation you're going to use, whether you're going to use a thio or a hydroxide formulation. You need to decide whether you're going to use a hot application or a cold application. The different hair types with your coarse, your medium and your fine textures are going to impact on all of your selections. So is your density and the degree of curl. And it's really, really important that you pay attention and think very carefully about what you're going to select to use on the hair type before you start. There is more information in your resources regarding this particular area. For example, if you had to chemically straighten a very strong coarse head of hair, you're likely to choose a stronger formulation, and you're likely to choose a thermal service as opposed to a cold service. Whereas a fine head of hair that may not be extremely curly may be okay with a cold application and just a mild formula. So selecting your type as well as your strength of your formulation is going to be important when you're considering hair type and the degree of curl that you're reducing. So just to recap, today we've looked at the different formulations for chemical straightening. We've talked about lye and no-lye formulations, and remembering that your sodium hydroxides fall into your lye and your weaker hydroxides and your thio technically is a no-lye formulation. We've looked at the chemical process and the difference between a hydroxide straightener, when it changes the hair shaft irreversibly, and a thio formulation that just impacts on those disulfide bonds. The chemical processes that we've talked about today are also in your resources, so you can refer to them for additional information. I've also gone over the key factors to consider when we're selecting our products, our formulations, and our method of straightening. And further information is available in your resources at Inditech Online.